Okay, so now let's look at some applications of logarithms. Population growth. So for this there is a formula. The final population, or let's write it, population final is equal to population initial times b to the power of kt. Now here, let's take the example of a bacteria. Let's say it is increasing or dividing 6 times daily. So starting estimate of its population is equal to 2000 units, and after 2 days it is 4500 units. So using the formula, let's figure out what is k, because that's like a constant of proportionality. So 4500 is equal to 2000 times 6 to the power of k times 2. Remember, 2 days. So 4500 divided by 2000, 5 nines, 5 fours, 6 to the power of 2k. 9 by 4 equal to 6 to the power of 2k. Now, the moment you see a variable as an exponent, then you know you have to use a log. You have to use logarithms. So log of 9 by 4 is equal to log of 6 to the power of 2k. Now this can be written as exponent can be brought down using the rules of log. This becomes 9 by 4 is 2.25. That means what? We can bring log 6 here, right, to begin with. So 2k is equal to 0.452588877. Let's bring in this 2 here. We get 0.22629438. So now what happens? What does this mean? It means that based on this experimental observation, we can customize this formula. Final population is equal to initial population times 6 to the power of k is 0.22629438 t. So that means you can now calculate what would be the population at any time. Now, this is k. It is very clearly understood that if k is less than 0, that means negative. That means the population is decreasing. If k is greater than 0, that is positive, population is increasing. Yes. So now using this formula, we can figure out, okay, after 4 days, what will be the population? After 5 days, what will be the population? This is a very simple example, remember, because there might be other limiting factors, right? Maybe the nutrients are not enough, because of which the growth cannot happen at this rate. But thinking of ideal conditions, this would give us the population. Okay, let's look at another application. Earthquake intensity, Richter scale. The formula for this is R is equal to log of A by T plus B. Now here A is nothing but the amplitude of vertical ground motion in micrometer. T is the period of seismic wave in seconds, and B is a weakening factor which depends on distance from so farther away from the epicenter, this factor would reduce. So which means we have to compensate so that we know the actual scale. Let's say the question is, what is the difference between a 6.0 Richter scale and a 7.0 Richter scale earthquakes? What should come to mind when you see a news item which says that there was an earthquake of 6 Richter scale and an earthquake of 7 Richter scale. Remember, it is not 6:7, right? That means it is not the same as the difference between 6 and 7. It is the difference that is there between 10 to the power of 6 and 10 to the power of 7. Let's divide both sides by 10 to the power of 6. What do you get? We get 1:10. That means the second earthquake is 10 times worse, 10 times more impactful than the first. Let's try to figure out the difference between 5.5 versus 5.75 Richter scale earthquakes. What is the difference? Remember, it is 10 to the power of 5.5 versus 10 to the power of 5.75. So 10 to the power of 5.5 would be 316,227.76 is to 562,311.325. Let's figure out the difference. This implies 246083.565 divided by 316,227.76, which is 0.778. So second quake is 0.778 times worse than the first. Basically, it is approximately twice. Okay, let's look at another area of application, acidity. And there is something called as a pH scale. The formula for that is negative log of H plus or hydronium. So H3O plus, let's H plus or H3O plus. And this is in moles per liter of hydrogen ions in a liter of the solution or solvent, to be more precise. Let's say you have been given a solution and you are told that H plus is equal to 4.5 times 10 to the power of minus 5, right? Hydrogen ions measurement shows 4.5 times 10 to the power of minus. So what is the pH? So pH would be minus log of 4.5 times 10 to the power of minus 5. If you do the calculations, you get 4.346787. By the way, pH scale goes from 1 to 14. In the middle, you have 7. So if it is less than 7, it is acid. If it is greater than 7, it is base. And if it is 7, it is neutral. So which means that our solution is acidic in nature. Okay, let's look at another application of decibel scale. Sound intensity. So decibel is equal to 10 times log of the power of one sound versus to the power of second. So which means it's a ratio, log of a ratio. So softest audible sound is when the sound has an intensity of 10 to the power of minus 12 watts per square feet. Now just when it gets painful, volume just painful, or what is called as threshold of pain, has a power of 1 watt per square feet. So our decibel would be, remember it's a ratio, 10 times log of 1 watt per square feet divided by 10 to the power of minus 12 watt per square feet. So 10 into log of 10 to the power of 12. These two gets cancelled. Now based on the rules, we can say 12 log 10. Remember, if nothing is there here, it is 10. So this becomes 1. So 120 decibel is just the amount of or the volume of sound that starts hurting. It starts creating pain. Okay. So these are some of the applications. So lots and lots of applications of log. So even if you don't use logarithms as such, the logarithm tables, this will be there in the calculator, because it's not just simplifying calculations. There are lots of applications. Okay, I think that's enough for today. Bye for now.